Our CCA for pre-calculus is on composite functions, specifically composite functions with word problems. So to start off with, let's just go through a warm-up of what a composite function is. This goes back to lesson 2 of this unit. So I'll go through a basic composite function and then we'll go through a couple of the word problems. So for the warm-up, we're looking for g of h of x. So just recall that if you see it written in this form, it's the same thing as writing g with an inside function of h of x, meaning you're evaluating the g function with h of x or with whatever h of x is. That's telling you you're taking this function, h of x, and you're substituting it in for x. So we have g of h of x, which is equal to the g function being evaluated at 2x minus 3. When we evaluate the g function at 2x minus 3, that's telling us that we have 4 times x, we're going to replace x, minus 8. We have 4, instead of x, we're going to use 2x minus 3, and then minus 8. We need to simplify this. In order to simplify, distribute your value of 4. We get 8x minus 12 minus 8. Simplify this one more time. 8x, negative 12 minus 8 would be negative 20. G of h of x is equal to 8x minus 20. Okay, so the first word problem says, in the mail, you receive a coupon for $5 off a pair of jeans. When you arrive at the store, you find that all jeans are 25% off. Let X represent the original cost of the jeans. So we have two things happening here. We have a coupon that's $5 off a pair of jeans, but we also have a discount of 25% off. So part A says to write a function f of x that represents the effect of your original coupon. The original coupon is the one you got in the mail, so that would be a coupon for $5 off a pair of jeans. And I'll do this one in purple. If it's telling us that x represents the cost of jeans, it would be the cost of jeans minus $5. Something as simple as that. This right here is your f of x function. The next part says to write a function g of x that represents the effect of the 25% discount at the store. So if you are representing a 25% discount, that means you're paying for 75% of the jeans. 100% minus 25% is equal to 75%. So if we write a function g of x, and I'll do this one in green, I highlighted it in green. Oops. This means that we would have a function of 0.75, which is the decimal of our percentage, 0.75 times x. This is telling us that we're paying for 75% of the full price. Make sure you don't do 25% times x. That's saying you're only paying for 25% of the full price. So it's super important that you do this right here. All right, part C says to write a composite function that represents how much you would pay if you use the mail coupon first, followed by the discount from the store. So the mail coupon, we used our f of x function, or we wrote this function as f of x. And our f of x function was x minus 5. So just a quick note on the side. If we're applying our mail coupon first, that means that is going to be the inside function. Okay, I'm going to label this h of x. You could pick whatever you want, but I'm just going to use h of x. H of x tells us that we're going to use f of x as our inside function. So it's going to be g of f of x, which is the same thing as the g function evaluated at x minus 5. F of x is this function here. That's where I replace that. All right, if we're evaluating the g function at x minus 5, this is the g function. Therefore, we have 0.75 times x minus 5. And you could multiply this out if you want, like you could distribute the 0.75 to get it in standard form, but I am fine with you leaving it in factored form. So this answer is good enough for me. H of x is equal to 0.75 times x minus 5. That indicates that you are applying the mail coupon first, followed by the store coupon, or the store discount. Okay, part D says to write a composite function that represents how much you would pay if you use the store discount first, followed by the mail coupon. So we are going to be using our g of x function first. G of x is 0.75 times x. And I'm going to write the same note as before. If we're applying this one first, then g of x is our inside function. I'm going to use j of x to label this. J of x is telling me that I'm using f of g of x. G of x is 0.75 times x. So I'm going to evaluate the f function at 0.75 times x. The f function is x minus 5, so I replace x with 0.75x minus 5. And our function is equal to just that, 0.75x minus 5. Okay, part E says you find a pair of jeans for $36. Which composition function would give you a better deal? If you're finding a pair of jeans for $36, let's go back up to the top. Right here, let X represent the original cost of the jeans. So in this case, all we would have to do is substitute 36 into our functions. I'm going to substitute them into what I labeled as H of X. And also what I labeled as j of x. And we're going to see which one is a better deal. So if I start with h of x is equal to 0.75 times x minus 5. I'm going to substitute 36 in for x. We have 0.75 times 36 minus 5. 36 minus 5 is 31, so 75% of 31, or 31 times 0.75, is equal to, oops, I can't, $23.25. So that's how much we would pay if we use the h of x function, which this function here represents the mail coupon first. Represents the mail coupon first, followed by the discount from the store. If we use the j of x function, which is 0.75 times x minus 5, and we substitute in 36, we get 0.75 times 36 minus 5. So 0.75 times 36 is 27, minus 5 is 22. So j of 36 is equal to $22. Okay, j of x is determined by using the store discount first, followed by the mail coupon. So we're looking at these two prices. Which one gives us a better deal? And hopefully you can all tell that the $22 is the better deal. Therefore, j of x is the function you would pick. J of x would give you a better deal. All right, and part F works the opposite way. So it says, if you only have $30 with you, what is the most expensive pair of jeans you can purchase using both functions? Okay, so $30 is the maximum amount that we can spend. Therefore, $30 would be our solution. So we're going to do the same thing as we did in part E as far as using both functions. But instead of substituting in a value for x, we're going to substitute a value in for the entire function. So we're going to start by identifying that h of x is when we use the mail coupon first, followed by the store discount, and it's represented by 0.75 times x minus 5. I am going to replace h of x with $30. So we have $30 is equal to 0.75 times x minus 5. I am not substituting in a value for x. I'm substituting in an answer for the function. So this $30 right here represents the total amount I want to spend. So the end amount that I want to spend. All right, I need to solve for x. What I'm going to do here is I'm going to distribute the value of 0.75. This gives me 30 is equal to 0.75 times x, and 0.75 times 5 is minus 3.75. I'm going to add 3.75 to both sides. That gives me 33.75 is equal to 0.75x. I'm going to divide both sides by 0.75. And when I do that, my solution is 45. Okay, this number is telling us that if we found a pair of jeans that was listed for $45 and we first applied our $5 off mail coupon, then we applied the 25% discount in the store, we would end up paying a total of $30. So $45 for the original price goes down to $30 after the discounts using the h of x function. I should be writing my answers in complete sentences, but for note-taking purposes, I think you guys can follow along with what I'm saying. All right, next we need to do the same thing with the j of x function. The j of x function applies the store discount first, followed by the mail coupon. All right, we're going to replace the entire function, so the answer of the function, with $30. Solve for x. And using the j of x function, if we only had $30 to spend, the most expensive pair of jeans that we could purchase is $46.67. So the j of x function would actually allow us to buy a more expensive pair of pants and still only pay $30. Okay, I'm gonna do out the on your own section. You guys can follow along here, or you can check the answers on my website. Either way, this is it for the review for the CCA. You'll notice that there's some extra practice. Let me know if you have any questions. The CCA will be tomorrow during class.